for being here. My talk today is about introducing what is Cloud Foundry, trying to give a general idea of what it's good for, what you can do with it. So as you said, my name is Alvaro. I work as a developer advocate for Cloud Foundry. That's where you can find me online. And don't know if you know, but I'm the guy behind Git sockets. It's getting a lot of press lately, like GitHub is talking about that and their open source talks. Google gave me a prize because of WebSocket. Wow. Microsoft presented WebSocket in one of their keynotes like 2 weeks ago. So, yeah, if you suffer that in your timeline, I'm that guy. And I'm co-author of that book, RabbitMQ in Action. So, yeah, if you want to know more about RabbitMQ, you should buy that. So let's go to Cloud Foundry. The idea is to talk about the capabilities of Cloud Foundry, so the basics, how it works, the architecture, and micro Cloud Foundry. So before starting, I don't know if any of you heard before about Cloud Foundry, okay, cool. So it's just like a platform as a service. It's different from Amazon in the sense like in Amazon you need to install all your system from scratch and so on. And here we offer a set of services and capabilities. So Cloud Foundry itself is more opinionated on what you can do and what you cannot do with the platform. And at the same time, you don't need to do so many ops, let's say. So there are advantages and disadvantages, of course. So I hope that we can have both clear today. And as I was talking before with him, I'm not the marketing guy, so I hope I'm not doing a marketing talk here because I will leave the room if I have that. So what does Cloud Foundry offer? So Cloud Foundry has like 3 main parts, and the first one is the framework and runtimes. So out of the box you have Java support, Scala, Ruby, and node.js. As languages you could write your applications on. But Cloud Foundry also has partners, that is other companies running Cloud Foundry, and then you can have like .NET, Python, PHP, Haskell, Erlang, and whatnot. So it's you have many opportunities of what you can actually do with Cloud Foundry. And in the case of Java, which I will show later, is for example, there is no support for Scala there. But in my case, I just wrote a tiny library, for Clojure. There is no, I wrote a tiny library in Clojure that also lets you write Clojure apps and then deploy them in Cloud Foundry because it's just a Java application at the end of the day. So you have that advantage by having Java. So that's for the framework, so it's what basically you could see down there on the right. You have Spring, Scala, Ruby, Rails, Node, and so on. So then on the cloud part, we have the public cloud, the private cloud, and the micro cloud. And what is that? So what is the main problem you have if you use something like Cloud Foundry? You will end up in the Hotel California, right? Like it's very easy to start, like you do VMC push, you have your app there, it's running, nice, you can show to your friends, but then you are tied to using what we offer. And the idea is to have something that is open, that everybody could run if they want in their own data centers. So Cloud Foundry, you can find it on GitHub, like github.com/Cloud Foundry. There we have many projects, like Bosch, for example, is the project used to deploy Cloud Foundry. There's people even using that for deploying their own stuff. And there you can also find Cloud Foundry itself. So you could fork that, download that, and build your own private cloud. For example, there are these partners, as we call them, like AppFog. They are specialized mostly in PHP, so they offer PHP support for your apps. In the case of CloudFoundry.com, which is what I'm talking about, we offer only, as I said, Ruby, Node.js, Java, Scala, and so on. So if you want to run PHP, you could go, for example, with the AppFog people, and they are actually just using Cloud Foundry with some extra plugins, let's say, or add-ons. Then the same is for Joyent or ActiveState, which offers Python, Perl, and so on. Recently, actually last Monday, Cloud Foundry released Cloud Foundry Core. I believe it was last Monday. The Cloud Foundry Core is basically a system that lets you detect if this cloud provider is compliant with the basics of what is Cloud Foundry. They can offer more stuff, but the basic will be tested by this Cloud Foundry Core. So they will want to be compatible with that Cloud Foundry Core. This means you will be able to port your app or to move your app from one provider to another provider. That's the main idea and one of the goals of Cloud Foundry, that you are not tied to us, basically. So as you can see, since the beginning, I'm basically telling you don't use Cloud Foundry. So let's move on. So then there is the micro Cloud Foundry. What is micro Cloud Foundry? Here you can download a VMware virtual machine that you can run on your own computer and basically have the same setup as what you have in Cloud Foundry locally, and from there test and run your apps. So those were the three kinds. Like the public is what we offer in .com and what other partners are offering. Then private, you can run your own cloud. And actually, I don't remember the exact name, but there is a pretty big Japanese e-commerce website. They run all their infrastructure in the private Cloud Foundry. They just downloaded what we have and use that. Because as you will see later, with Cloud Foundry, it's very easy to have an application that you stage it, and then you have one instance. If you need to have, let's say, 20 instances of that app, you could do that, and so on. So for their needs, they are using Cloud Foundry. And then the third part is the services. So in Cloud Foundry, we have, what you see down here, like Postgres, RabbitMQ, Redis, MongoDB, MySQL. And basically, they let you do more than just running an app. Like, okay, you have a node.js app or something, but you probably want to store data somewhere or communicate in your app or stuff like that. So for that, of course, you will want to run any of those services. And the cool thing about Cloud Foundry, and it's something I use in the demo app I will show later, is that you can share your services across the applications. That is, you have your account in Cloud Foundry. This account will have certain capacity of how many applications you can run for that account. That is the amount of disk space and RAM that we provide you. And you have a certain amount of services that you can link to that account. So you could start a MySQL service that is tied to your account. What that means is that you deploy one app and you say, I want to use this MySQL service, then you deploy another app, and that app could also, if you want, be bound to that MySQL service. So there you have shared data across your apps. The same you can do with RabbitMQ, Redis, and so on. So you can have a public-facing store, let's say, and then the admin part could be another app in Cloud Foundry, but they will use the same data in the same services, basically. And yeah, so with the Cloud Controller and the API, there is a way, let's say, to have a new service, to destroy a service, to stage it, and so on. So if you look at the code in Cloud Foundry in GitHub, you will see that like creating new languages, let's say, like an Erlang support. There is already for Cloud Foundry, but that's an example. It's just a matter of looking at how to expose that to the Cloud Controller. The same for services. So if tomorrow you want to, I don't know, have RavenDB, which is the latest buzzword on the database world, you could do that with Cloud Foundry. Of course, that doesn't mean it will be part of cloudfoundry.com. That's what the difference between the public cloud, that is what we offer at .com, versus what we have at .org. So whatever you find in cloudfoundry.org is open source. Like we talk about community contributions, everything goes there. And in the .com is what happens in the service that VMware offers. And that service at the moment is in beta, but the idea is to have it in production at the beginning of next year. So there we will have a service license agreement, and what kind of reliability we offer, and so on. But this is not there yet. So far we only have free beta accounts, let's say. So yeah, a service is for you cost nothing. So to support, let's say, RabbitMQ, you just say on the... So Cloud Foundry has an API. You talk to that API with a client, to the cloud controller. In the case, most common in the command line, you will have a program called BMC, which is just a Ruby program. And then you will do like BMC add service, blah, 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 MySQL. And then you will have your MySQL service, and so on. So that's basically how you add services. You don't need to do anything else on your app. And even better, like for frameworks like Node.js and I believe the Spring, you have auto configuration of services. So at the moment, let's say, or before we had that, like back in June, for example, if you wanted to use MySQL or RabbitMQ or whatever from Node.js, you had to parse an environment variable, very nice, which was JSON data with the services information, like your user, password, and so on. Because again, you don't know where your application will run. You don't know to which host it needs to connect, and so on. You can have like 5 MySQL instances running, and so on and so on. So before, you had to parse that JSON value from the command line, find out where was MySQL actually running, what were the credentials, what was your database, blah, 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 and there you could connect to MySQL. Today, in the case of JavaScript and Node.js, they are doing something. Somebody please stop recording now. They are doing monkey patching. You can continue recording now. So they will monkey patch your code in production, and they will, like, in JavaScript you call MongoDB connect. So when you have this MongoDB connect, they will detect that you're calling that, and actually they will call connect with the parameters that Cloud Foundry or your app needs. And I don't know what's the way they do it in Spring, but it's basically the same idea. You just code locally for your local database, and then I believe you have like a profile or something like that for the cloud where they find the right parameters for the services. So the idea is really that you don't need to do much to have your app up and running. And yeah, as I said, you have Redis, MongoDB, RabbitMQ, and so on. So I will try to do a demo. This is the part where I start to sweat and shake my arms. So please don't call a doctor, it's normal. So what happens in Cloud Foundry? So I have a very basic Node.js app here. I hope everybody can see that, or let's put some colors. So this is a Node.js app that I want to deploy to Cloud Foundry. So I just get a Node.js server, I create the server, and I put it up and running. So if I just run this from the command line, I should have a Node.js server running on that port. That's basically what this does. And in the command line, what you do is you use everything with this BMC gem, which you just do, I think it's gem install BMC or something like that in Ruby. So I could do like info and see where is like the basic information for the system. So something that's very important there, it says target, and it says HTTP, API, my name, and so on. That actually is targeting the microcloud that I have installed in my Mac. But actually I want to show this with the real Cloud Foundry. So what you do is just to target HTTP API cloudfoundry.com. And there I'm targeting cloudfoundry.com. So this is, again, you can run Cloud Foundry in many places. I could probably do API appfog.com, or I don't know what is their API, but basically it's just talking to the cloud controllers over a REST API. If you don't like BMC, you could implement something like that in Java, which actually there is a client for Java, or maybe some Cocoa app for the Mac where you can do everything clicking around. I don't know. It's up to you or to the partner, let's say, to see what they offer to the final client, or build like a Backbone.js app in the browser, all beautiful there, just talking to the API. Anyway, so then after you do the targeting, you need to log in. For example, I can try with this account. So we'll ask for my password. Please. Yeah. And I could see if I have any app. So I have the Hello Zurich app that I did yesterday. I will just delete that. Yeah, let's see. Bye-bye. So the app is gone. So how do you do a deployment? So I have this basic app I said before. You will do BMC push. That should get the app there. And it will say, okay, would you like to deploy from the current directory? Yes, of course. The application name, again, Hello Zurich. I hope nobody took that URL in between. So there it detected that is a node.js app. It could detect that is a Spring app or something like that. Like in the case of the closure thingy I made, there is no detection at the moment in BMC for closure apps. So you will need to provide a command on how to actually execute your app. Because in Cloud Foundry, it won't be like reading your mind. So for many frameworks, it's already there, the support to auto-detect, but for some, you need to do it manually. So yes. So that will be the URL I will need to open. This one, let's copy it here. You can specify how much RAM you want. So it's a Node.js app. You will try that with a Java app and you will see like 500 something megabytes by default. Then the amount of instances you want to run, I just want one. And then we can see if we want to, for example, add any service. At the moment, I don't have any service. And here you can say if you want to save the config or not. So this is, do you want to actually reply to this question again, or you want to save that somewhere? So if I do yes, then this is written to the manifest.yaml. And there the app is deployed. So now I can do that. And that's the app that I deployed. Very simple and right. Not so much rocket science there. But what's cool, as I said before, this is running locally in the port 1337, but actually that's not the case in Cloud Foundry. I don't remember exactly what's the code, but in Node.js, but if I will get the bcap services variable from the command line, I could get the actual port that this app is running. So before, I think, I mean, I don't remember exactly, but let's say the code will be something like this: node m bcap services. Again, I don't know the exact Node.js code to get a variable from the command line, but you will get that, which will be some JSON object, right? And there you will have your port, and this will be something. I mean, a port usually is a number, not strings, and you will need to do something with that port, pass it to listen. So here in the previous code, you will have to do like if Cloud Foundry do that port parsing, else run with the 1337, blah, 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 blah. So you get the idea, right? What Cloud Foundry did now was to automatically know that actually I wanted to have a server here. I mean, a HTTP server, and then it just changed the port the server is listening without me needing to actually change the code. So then you can do like VMC info okay, I did that, sorry, stats about your account. So that's what the application is doing right now. You can get the logs from Hello Zurich, if there are any logs. So I said I logged. I mean, you can see here what. Sorry. I just logged here this, which is not true when it's going in the real app. You can see I don't have the port there, but I mean you can see it's that code running and so on. Then there are many more commands. I think if I just type help, probably, yeah, there you have a few to choose and to get the options using help, like command plus help. But basically what you will do is like stop the app, so be Hello Zurich, for example, or delete, things like that. The detail that you need to keep in mind is that you don't push again. If I want to do a change to the app, then you need to do update. That's basically the only change from deploying your app for the first time versus having it there. I mean, doing an update. And of course, you will need to, like, if you add MongoDB, let's say, you will have to restart the app so it will connect to MongoDB and, I mean, get the new code and so on. So there are some things you will always need to do, like restart or so on. So I don't know if you have any questions so far. I've been maybe too fast, too slow, or do something. Yeah.
When we do an update, it's
yes.
copying everything that we have on the directory, because if we're adding more codes or more files and so on.
Yeah.
Copy everything.
As far as I understand, it will do a diff from what you have, and I think it's
always sending
zips and send everything out.
Okay, so it
and I think you can even have a VMC ignore file to ignore folders and stuff like that.
Okay.
So in the web there is a document, I don't remember, like VMC usage. I'm sorry, I don't remember the name, but VMC quick reference. So there you can see all the options, like, for example, I didn't show that, but VMC services will show you the services you have, then you can create a new one, like service type, service instance name, and so on. And yeah, or update the detail and so on. And I didn't show it, I think. Yeah, I have this file here. The manifest is basically what I created when I did the save, that I did the deploy or the push, and then I saved everything I wrote there. So you can see it saves the name, the framework's node, the memory I want, and so on. So here is not much, but if you declare like 6 or 7 services, each service will have its own name, and so on and so on. So this will be much bigger, and you will need to answer many more options every time you deploy. Also, let's say a colleague wants to deploy your app, and then you could document that you actually need to have MongoDB running, MySQL, and so on, but you could also just have the manifest, and there is everything that the app should need to I mean, that needs up and running before the app can be started. So, because you were the first one asking a question, here we go. There are t-shirts.
Thanks.
I only have one size, so or will be good for you or too small to be. Sorry.
Is there specific support for continuous integration systems like Jenkins or so, or do you have to do this yourself?
Yeah, this you need to run locally in your own machine or something like that.
Or on the server?
Yeah, exactly. Whenever you have Jenkins. So
it's a negative question, but
doesn't matter.
Okay.
I don't have enough, but please don't come with silly questions now. You all know my name and you have watches to check your time if you want. I won't be answering what time is it. So where it was? Okay, so that's basically it, like how you log in, how you target the cloud. That's very important that you know to which API you're talking. So again, you could be in the local one and so on. You can have many users, so you need to log in and see which user you want to use. Then asking questions, yeah, you can see the information, stats, stuff like that, and then you can deploy from the command line. So a bit about the architecture. So basically, how does Cloud Foundry works? So the first part is the DEAs, which are the droplet execution agent. There are hundreds of them running in the Cloud Foundry infrastructure, and basically they know how to execute a droplet. What's a droplet? A droplet is like a package that has your app and the minimum needed to run your app, like in the like a node.js app or a Spring app and so on. Then there is like a start.sh command, stop.sh command, stuff like that in your droplet. So when we do the detection, remember that the VMC client, when I was doing the push, was asking me which runtime you actually need, which framework, like Node.js, Java, and so on. So some DEAs will be ready to execute Ruby apps. Others will be ready to execute Java apps, and so on. So when we deploy, like the VMC will talk to the cloud controller, VMC or any other client, of course. And from there, the cloud controller will need, okay, I need to start 3 instances of a Ruby application. So some DEAs will advertise, okay, I'm ready to run this app. So then they will get the droplet and execute it. That's basically how it works. The same happens with the services. We will need probably RabbitMQ or MySQL and so on. So some services will be started for you and bound to the app. So once the application is ready, the router will be told that there is a new app to run on this URL, and then this will be added to the load balancer. So you saw I have hello.sh that will be added to the router, and then the load balancer and so on will manage to send the request to the DEAs. And then there is a health manager that takes care that the services are running or your apps are running, depending on how many instances you wanted to have. And this service or system is eventually consistent. What does it mean in this case is that you may be asked for 3 instances of your app, but you may have 4. Because when the cloud controller asks to run the app, maybe 4 or 5 of the DEAs advertise, oh yeah, I'm ready to take the work. They will send the work, but then if there are 2 that are more than what you actually asked, so the health manager and so on take care of making the system reach the state that you actually desire. So at the beginning, you could have 1 more and so on, doesn't matter. With time, it will actually go down or up to what you actually requested. So that's how it's managed there. And everything is implemented with this message bus, which is also was created by the Cloud Foundry guys. Yes?
How do you handle crashing apps or logging and these kind of things?
I will talk about that in the future. Yes, I don't want to hit anybody, so you can pick it up later. So, yeah, I mean, if the application crashes, there are things to do. If the DEA crashes, there are things to do and stuff like that. Sometimes you will have an availability, sometimes not, depending on what crashed from your app. And for logs, you also have logs, as I showed in the command line, and you have crash logs as well. So you can get all this info. So again, you do the push, then you get the which framework you want to run. You create the app. The cloud controller will create the droplets for your the framework. There is a plugin for each framework. As I say, you can create your own plugin to run Erlang apps, PHP apps, or I don't know, Ada, or what is it, APL? I don't know, something from the very far away past, and you could run it there. And then when this knows which framework needs to run, has a droplet, and then it will find the DEA for your app. One of the DEA will say, yes, I'm available, and it will deploy the droplet. The application will be started, then the routes will be updated for your app, as I said before. So we have this station plugin. I don't know if you noticed, but at some point when I was deploying, it said station app, then was starting app, and there were like 2 steps. So the station will do this zip filing thingy with the start and stop command. And in the case of when your app is already running, you have the HTTP request that goes to the load balancer, there to the router, and back to your application. So that's basically how it works. And the question sometimes happens, with Cloud Foundry we mostly offer, or we only offer HTTP apps. So you cannot start RabbitMQ servers and consume locally, for example. No, you need to have an app in Cloud Foundry to be able to use RabbitMQ, that particular server instance. So you cannot use Cloud Foundry as a cloud RabbitMQ or cloud Redis. You could use it for your apps in Cloud Foundry, but not remotely. For that, there is a service called Caldecott, which can tunnel your app to your local machine. So if you need to log in to MySQL to do debugging or stuff like that, you could do that with this Caldecott. And it's called like that, I've been told, because there is a tunnel in Palo Alto or around there, which this guy's going to work at VMware, need to cross every day or something like that. So they call this app Caldecott. Yes. What's your question?
So does it do HTTPS as well?
I think that it doesn't at the moment. I'm not 100% sure. You get it. There you go. So, yeah, this is, I think, is related to your question before about how does the health of the system behaves or what happened. So when there is an exit on the application, the DA will do a broadcast of the message, and the routers will remove the app from there. So that particular instance, so it doesn't get any more requests. And then the cloud controller will know that and will relaunch the app. I don't know how many times that is tried, but if you have a trashy app, you won't have that. I mean, this app won't be able to be reached. That's pretty obvious. And if the VM crashes, then of course the instances running on that VM will be unavailable. So this might affect you and maybe some other guy. It depends on which kind of event plan you have. So at the moment, we have, as I said, we are in beta. So you have certain amount of RAM, certain amount of disk space, and so on. But if in the future, when we have paid Cloud Foundry as well, you may want to have a better availability, or have a machine only for yourself, or like some more computing power, or something like that. So in the future, maybe, I mean, if that VM crashes, it's only your stuff there and not share or something like that, which can happen today. Like we have a DEA for node.js, and then it can be running my Hello Zurich app and your Hello something else. So that's how it goes. So micro cloud Foundry. So I talked a bit about that before. Basically, it's Cloud Foundry packed as a VMware virtual machine. So the idea is that you can do testing or developing locally and have like faster responses and so on. So what you need is to have at least 1 gigabyte of free RAM, of course, not just one, because then your operating system probably needs to run. You need to have 8 gigabytes of hard drive, connectivity with internet, that usually today is not a problem, at least in this part of the world. VMware Fusion or any of these products, and command lines for VMC or Eclipse STS if you use Eclipse, for example. This is just for deployment, not actually for installing micro cloud Foundry. So you can have register an account and log in there, and this will let you get a micro cloud Foundry for download. So when you go to the micro cloud Foundry domain, you choose what is your micro cloud Foundry subdomain. In my case, I don't know if you remember from today, it was AV data. That was my subdomain there. And what this will allow is that you could open that URL on your browser and redirect to your app directly and basically set up everything for you. So it will give you like a configuration token, and when you configure your micro cloud Foundry, you will use that token to set up your domain. So after you get the download, you start the virtual machine, and then you can set up your password and your user for that virtual machine, basically, and then you do the update of the DNS and so on, and this will automatically configure your micro cloud Foundry. So I could show you a bit here, but that's not my goal today. So here I have the micro cloud Foundry running. Sorry if you cannot see it, but something like that. So you get that console where you can refresh the console DNS, reconfigure the password and everything for your micro cloud. And then you need to target what you see here. Oops, sorry. This, or your URL from your micro cloud Foundry, and then you will run locally. So I think I can do that here. So HTTP API. Oh yeah. Sorry for that. Thanks. So there I'm now talking to this virtual machine basically. And what I can do now is like users, because I'm an admin, I can see which user I have, and that's the user there, so I can log in. And I have this app running, and you can see even I have services like RabbitMQ, MongoDB, Redis, and so on. And I could target or see it here. I hope, yeah. And yeah, I will demo this app. This is the closure node.js part data. But that this app now is running on my micro cloud Foundry, and that one is running on the public cloud Foundry. So please don't upload any FSK18 pictures. I don't want to need to shut down this. Okay, let me continue. So if you want to start using Cloud Foundry today, this promo code is for here. I asked for today, so you could use that promo code if you want to write it down or something. And then you will be automatically registered. Else, you will need to wait. Since somebody that crosses the Caldecott channel will start clicking your Yeah, and approving your email. So write down that. And they're in the Pacific time zone. So after you register, you will get an email with a password. And then you will use it, as I say, with VMC or with any of the other IDEs that can use Cloud Foundry. I even think that Cloud9 IDE is a cloud editor, so you can edit in the browser, and you can even deploy from there to Cloud Foundry, if I'm not mistaken. And then, yeah, this VMC that I had already, you do gem install VMC, target the cloud you want to use, login, push if you want to bind services, update if you have the new version of your app, and you can even increase the instances. Of course, you probably cannot do 100 because you won't have enough RAM in your beta account that you could potentially. And that's something pretty cool. Like you know you will have more users in your application because, I don't know, you got hackers nude or what was it before, Slashdot, and yeah, from some time ago. And yeah, you can just start more apps and have everything running. Of course, you need to prepare your app to be, let's say, cloud ready, because it's not like you just create more instances and everything work. As I will show in the app, I will demo later. There are some details that is part of the architecture of the app. It's not Cloud Foundry's fault. I mean, there is no magic in the software world, as you know. And yeah, sometimes if your app is completely stateless, firing more instances is for free. But if you have state or something that you share, you need to make or be sure that you know how to handle that. Yeah, so you can have it on Windows with the Ruby installer and the VMC gem afterwards. And on Mac, you can just use the RVM, for example. Then this I showed already, VMC target and login. There is this plugin for Eclipse. So this plugin is quite cool because you can kind of drag and drop the cloud and just set up some parameters on this window and you get everything ready. Yeah, you can see there, even you can specify the, where's my mouse? I cannot do this here, so here. You can have 4 instances or do all the stuff there in the plugin for Eclipse. And now to the showtime, so I hope this also keeps working. So Clustergram, the idea of this app I showed you already, is to be a clone of Instagram in Cloud Foundry. Of course, it works with upload of pictures instead of taking the photograph, because when I wrote it back in June, there was no API in the iPhone to actually take the picture and do the upload, unless you will do a lot of pain of installing a second part or third-party app and stuff like that. So it works with uploads, but basically is to say, okay, I'm a user, I have followers, I have people I follow, I can upload pictures, I can comment on the pictures, and if I follow somebody, then I get their pictures on my timeline. Then it also has a global timeline where I see all the pictures that people is uploading, stuff like that. And the idea was to also be real time, so use Sock.js and WebSocket to broadcast every time there is a new image. Then image resizing is done with RabbitMQ, so you have all the workers you may want to have or only one and stuff like that. So there are a lot of details, even though when you look at the website here, it seems pretty basic, just like an image gallery. But then you have this, like the latest images, or if I go to a user, I can actually, I can't follow myself, but I could follow a user, stuff like that. So, back to the game. So what's the idea behind this app? It's like you can have one or many instances of this app running, then there is RabbitMQ there, and they all could communicate using Rabbit. And if I have a separate app in Cloud Foundry, I could also talk using RabbitMQ. That's the part where you can share services. So because of that, doing this is for free, basically. The front end is written in node.js, and the backend, these image resizers, are also in Node. But later, because I heard in Hacker News that you should use Clojure, I changed to Clojure, and that's also for free because I was using Rabbit. Of course, I didn't do Hacker News oriented development. I wanted to use Clojure. And so yeah, you probably want to see the code or it didn't happen, right? So first, I will do a small demo for those of you that never saw me before and hear me talking about RabbitMQ like a crazy guy. So this is a small simulator I brought for Rabbit. The idea is to demo how Rabbit works. So RabbitMQ is a messaging server. So it's to get data from one app to another app or from one process to a different process. So for that, you have like publishers and consumers, people or apps that want to get data and apps that want to publish data. You need an address. So every time you send a message, the message needs to go somewhere. That somewhere is an exchange in the concepts of RabbitMQ. So you would say, okay, this publisher will send messages there. And when I send the messages, nothing happens. Why? Because I need to have queues. The exchange is basically, okay, you send message, but you don't have any queue bound to the exchange, then the exchange will just throw the message away. In this case, I say, okay, no, I actually want that the messages are routed to this queue. So whenever I send messages, they will go there. Of course, I could have more than one queue and do fan-out kind of communication. But again, still so far nothing happens. And these queues, they have the, oops, nice demo. Sorry. You never see anything there. The queues, they are queuing messages. So if I do like that, I just have the messages there. But when I actually subscribe to the queue, I start getting the messages out of the queue. I can also do message run robin. So if you need to resize image faster, for example, you will have more than one worker and stuff like that. Then let's say you just don't want to only resize the image, you maybe want to also send an email or something like that every time a user uploads an image. So you have a new queue, send the messages as you saw already, they will get there. You have the email sender worker that will grab the message and do something. So basically that's the 1 minute view of what RabbitMQ does or how it works, because I will be talking about that now in the presentation. So here I have this app, which is ClusterAmp, and it's just a typical Node.js application. You can see like it uses a lot of Node libraries. It's using the Express.js framework for routing and so on, EGS for templates, MIME to detect the MIME types of the pictures, blah, 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 blah. Right? So there is a route, which is in route, yeah, that handles the image upload. So every time I upload a picture, it's here. Every time I do a new image upload, I will store the image on MongoDB. This library is taking care of that. And if this succeeds, I don't know how many of you know Node.js? JavaScript? Okay. So Node.js is basically JavaScript running on the backend, on the server. So as you know, in JavaScript you have callbacks, and because it's kind of a functional language, and please people doing functional programming don't hit me for saying that, but in JavaScript you can pass functions as arguments to your function, and in this case I just pass a callback. So if the image store succeeds, this code will be executed, and basically I create an object. This is what I want to send around with RabbitMQ. This object has the user ID, that is who uploaded the picture, the file name, the comment, if there was a comment, the date when the image was uploaded, and so on. And what I do is just to publish the message to this exchange and using that data. And the last empty argument is the routing key. In RabbitMQ, you have routing keys when you send messages, like they can act as filters for the messages. So that's it. I uploaded the picture and then I just did, there is a new image. In a more traditional website, I could actually return here and just show the picture whatever was that the user uploaded. But actually, I want to do an image resize, for example. So let's get out of Emacs and see where this is being used. Okay, so we can see that this resize library or module is using that cluster and upload exchange, whatever that is. So let's check there what's there. So here I declare a consumer. So this consumer wants to get messages that are published to the cluster and upload exchange, and it wants to have its own queue called resize. There is no routing key for the messages. And whenever there is a new message here, I will execute this callback. So I read the image from the image storage, which is grid FS in MongoDB, based on the message file name. So we trust the information that's coming there. We see, okay, that's the file name that I want to resize. If we find the image in MongoDB, we do the resize using image magic in this case. And if this resize succeeded, at this point here, we store the file, the small one, in gridfs again, with a different file name. Yeah, the file name is here, which is small underscore the image name. And if storing the image on the small one, the thumbnail, succeeded, we have a new message. So this is a messaging pattern called pipes and filters. So it is, I process this here, when I'm ready, I give it to the next one, which could do nothing or do something else. And it's pipes and filters because, like I think in the factory, when you can imagine when you have a product going through whatever the machine name is, somebody will put it inside a box, the next guy will put a label, the other guy will seal the box, and so on. So the pipes and filter pattern in messaging is basically that. I do something, push it to the next address, in this case, cluster and new image, and there might be somebody doing something there or nobody. And that is another advantage of messaging. Again, I could just finish the process here and have the thumbnail shown on the website, or actually open the door for more actions in the future. Some actions that are not even in today's requirements for this project. But we have the flexibility. We have the flexibility here, as I showed in the small simulator demo, of add a new queue, let's say a new consumer, which will be bar some consumer. Then the exchange will be some, cluster and upload. Queue will be new queue. And a callback, basically. I mean, you know the other part, right? So with that, I can actually have something else done on the messages that I get on that exchange. So this is an advantage that we get by using messaging in our architecture. So let's find down here, where was it? Cluster and new image. What's going on here? So, okay, it was in that file that I was using the cluster and new image. So I must have some consumer down there. Let me- yeah. Sorry if I make you dizzy with all this jumping around. So this consumer, it's called add image to user consumer. So what is it doing? Of course, it declares its own queue, whatever. But basically, in the callback, there is a module here which takes care of adding images to the actual user that uploaded the picture. So if for some reason resizing didn't work, we don't want the image to be displayed to the user. So because it actually worked, I will just push that. And in this case, user images is a module using Redis. So we have MongoDB as blob storage, basically, and Redis as a way to keep like a list of images per user, a list of followers, a list of comments per image, stuff like that. In this case, because we have a new image, we push that to the user image. And we can even see that we do something else afterward. We even have this publish pubstat message, cluster and broadcast new image, whatever that is. Let's keep with the new image for now. So in this case, we have a new image consumer. What's that? So again, there is a latest image list, which is what you see here. These are the latest images uploaded to the website. Okay, Philip was using the website, and it worked. And this image was uploaded by him, right? He's trying to kill some food, I think. So as I said before, I can even follow him, and then I will get his images real time in my list and so on. But that part just takes care of putting this image here. If that wasn't working, that knife wouldn't be there. So don't invite him next time, please. I don't want that. Then latest image is okay there, and finally, this is what I mentioned: add image to followers. So there was a new image. I have followers in this cluster ramp, so I will get their images in real time in my feed. And that's it. So there you can see the pipes and the filters going and going on, all using the services that Cloud Foundry provides, like Redis for all these interactions, RabbitMQ for the real-time messaging, and MongoDB for the actual image storage. But we have this final piece, and here's where I told you before that you need to take care that if you want to have many instances in your app, you actually will need to be smart about how you call your app. Or do something. I don't want to pretend that I'm smart. Just need to do something that the app will work, basically. So let's act for that. And we have notify users. There is a module that do something with that message. So again, emacs notify users. And here I have a SockJS module. SockJS is basically an open source project that implements WebSockets across browsers and platforms. So if your browser doesn't support the actual WebSocket, SockJS will emulate them on that particular platform. And for the server side, there is a SockJS node.js server that will do the server side thingy. So again, this one, whenever there is a new image to broadcast, we'll get that. And in this case, I have broadcast. It's a module that is doing the connection to the browser, so it keeps a list of connected users and will send to the user that there is a new image. So as you can see here, this is to the uploader. So if I do an upload here, let me refresh. So it should work, I hope. I have a new image here, open. Hello, upload. And that appeared real time. That is actually sent from the Node.js server to myself. So, would you mind uploading a new picture, or you are off of the website? So, what should happen there is if I am following him there, and then I'm in my timeline, when he uploads a picture, that picture should also appear in real time there. So this happens here. Broadcast the image to the follower. So in this case, here is where it gets a bit, just a second, where it gets a bit complex, and when I say that you have to take care of having many instances. So this browser is connected to some Cloud Foundry instance of my app, which is somewhere here, I think I put it. Yeah. Current Cloud Foundry instance for this app, that's the ID of the instance. Doesn't matter, but I should put that to debug that I was actually running in different instances. Where I want to go there. So this browser is connected to that particular Cloud Foundry instance, but maybe his browser is connected to a different one. So the node.js server that keeps my connection here, of course, is not in the other one. This was on. Yes, yeah. And yeah, I mean, what happens is like maybe he's sent to another instance. I have my instance there, but then the communication with RabbitMQ makes possible that I broadcast, as I say there, the message of the new image across all the app instances. And if you don't take care about that, it can happen that your message never arrives to the other guy because you are considering that you only run one instance of the app, or you get the message many times, so you need to keep into account or see how to orchestrate that so this guy doesn't get twice the broadcast, or many things could happen when you have more than one instance. And that you should just create your app, see what happens, or think in advance, and try to not get the 20 times the same picture there. Yes?
How does the app knows on which like DA this is running? Or
you don't know in which DA you run, you know the instance basically of your app. So one DA can have many apps running. Yours or not yours.
But when the router only supports HTTP, how does it know where to connect the socket?
This is all done. I mean, in the front, I think there is Nginx, and from there, what is it? I mean, I don't know the exactly. Well, I know
I guess this was the automatic shutdown. I thought I stopped it, but
it's 8 already.
Okay, so maybe it will still take a minute.
I assume this will be called as hell.
Sorry about that. It's a new system and nobody knows how it's going to fix it. At least I don't know.
So I will try to be quick. So basically you have the load balancer has the router, and the router knows how to find your app. This is all registered in the Cloud Foundry infrastructure. So you don't actually need to care about that. The only thing you need to care if you want to always be sent to the same instance, that is, this browser always goes to the same instance, is to use the J session ID, like in Tomcat, I think, has this cookie. So if you have this setting, you can always target one browser to one particular instance. But if you have your session stored, let's say, in Redis, you don't really need that, because by the cookie name or some way you can identify which session data to read out of Redis, for example. So I don't know if it's clear or.
But the socket, is it governing over HTTP or is it a real socket connection?
For WebSocket works over HTTP.
Oh.
So WebSocket basically does the upgrade of the. So you have an HTTP connection, and then I think at some point asks to upgrade to WebSockets. But else they will simulate with long polling or something like that if your browser doesn't have the capabilities. But this is something SockJS specific, not really Cloud Foundry specific. And this for you, and I think this was yours. Yeah. What?
I don't have anything to say now.
Okay, so you lost your t-shirt.
Yeah. No question.
Why is that? Okay. So again, what I just was trying to make the point here, with messaging you can have many steps for processing an event, and in Cloud Foundry that's basically for free because you have RabbitMQ there already, and there are libraries for all the platforms that we support in Cloud Foundry, like Ruby, Java, and node.js and so on. And then there you can do many patterns like what I tried to demo here, like how to broadcast to many browsers and stuff like that. So, any questions so far? No? Don't be afraid. There are only two digits. So, micro, demo. Yeah, closure. Somebody mentioned closure there. So, this is another advantage of being using messaging, and also what Cloud Foundry supports. You have polyglot application if you want, because you can connect with or use many languages. And in the case of RabbitMQ, which is not there yet in Cloud Foundry, because Cloud Foundry has a version 2.4, I think, which is about to be upgraded, and RabbitMQ got the 3.0 this week. But in Rabbit, you can also have many protocols, not only AMQP, which is the protocol supported by RabbitMQ. Today, for example, is very popular, the Internet of Things thing. And there you may have many devices with low battery and so on, and there is a protocol called MQTT, which is used by Facebook in their iPhone app, for example. And with MQTT, you can also talk to RabbitMQ, you can talk using Stomp and so on. So even if this sounds very buzzwordy, with Rabbit, and you can have many languages, because there are libraries for many languages and many protocols, so you can be polyglot, let's say, in many ways, so to say. Anyway, so I have the resizer that I showed here before, right? But if I totally comment out this code, take it away, I could do the resize, for example, what I did in Closure. So here I have a resize wrap that has a consumer. Sorry for the Closure code for those that don't like Lisp language. So basically I have a consumer. The consumer will listen to the queue. Again, you can see it's using the same exchange, the resize queue that I had before. And what I will do when I have to process a new message, I have a library here in Closure. This part is the important one that will process the image, whatever that is. In this case, it's doing the resize. So I really just implemented what I had in Node.js for the resize part in Closure. Oops. And once this is over, I send again cluster and new image. I publish the message again using the Closure code. That's the main difference. That's it. So I compile that code, whatever, and then I need to deploy the shard. So I have this folder here. I have the jar that built with Closure and all the libraries. And then, because I already deployed that, I have a manifest which says, in this case, I need 500 megabytes of memory. I think it's not so much for this app, but that's, I think, the default for Java. Then it's a standalone app, so it's not an app that will have a public URL. So this is something you could do in Cloud Foundry, to have apps without public URL, for example, just to consume something out of a service. That could be done. Then these services will be bound to the app. Actually, the app only needs RabbitMQ and MongoDB. It's not using Redis for anything, but I will use the exact same MongoDB service that the Node.js app is using, and the same RabbitMQ. As you can see, there is no URL for the app because there is no HTTP here. This is the name the app will get. The runtime will be in Java. We also support Java 7. The amount of instances, so here it will really make sense to have more than one, because maybe I want to have more workers processing messages. And as I said before, because there is no, Cloud Foundry doesn't know what to do. Okay, it's a standalone app, cool, it's Java, yeah, perfect, but how do I get your app up and running? You need to run this Java command. It's very important that you have the options there, this. And then the class path and how you will start a default closure namespace, basically. That's it. There is no more than that. And by doing that, I can, let me see, I think I'm targeting my local Cloud Foundry services. Yeah, it's the same anyway. So I think this comes from my local micro cloud, but anyway, you can see there that I have MongoDB, RabbitMQ, and so on. These are the services that are provisioned. Then if I do VMC apps, this is the, where's my mouse? Here. The web facing part, the node.js part, and this is the closure part. And all this, they are deployed. Actually, the cluster run part has 2 instances, and this one has only 1, and so on. So by just using Rabbit and like a service provided by Cloud Foundry, I could switch one part of the implementation of my app. Let's say because Node.js wasn't that fast to do the image resizing, I could do the implementation in Java and then get it faster or whatever. And because of the multi-framework support in Cloud Foundry, it's just to deploy that again. So, any questions? Yeah.
Is it possible to deploy different kind of services? So I saw that you have like Mongo 2.0.
Yeah.
If you want to use a different version, like 2.2?
No, you are restricted to what we have there. So you cannot say, you have the latest RabbitMQ, for example, that was released 1 week ago, and you want to have that. You could have that in your private cloud, but not in the .com offering, and the same with any other provider like Appfo or whatever. You are restricted to what they have and the runtimes they have and so on. For example, I think in the case of the runtimes, I think it's like that. Oh, yeah. And also you can see this was a bit slow to reply. Why? Because it's actually just talking to the cloud controller through the REST API, getting the information back. BMC doesn't have any info here. It's all HTTP. And you can see there are 2 versions of Ruby. So you could say BMC push runtime Ruby 19, for example. But in the case of the services, no, there is only one version of MongoDB or one version of each of them. So that's what you have, basically. So, you know what happens. And the last one is already reserved. We keep it here. Yeah.
What are the possibilities to run like commands in the context of my application on the cloud? So the typical thing is like running a shell in the context of your application or running management commands.
So the idea most of the time is that we manage the app. Like that's the idea of the platform as a service, or one of the ideas that you need to do as less ops as possible. Of course, in the real world, you will need to do ops anyway. For that is what I mentioned before, is this, I think it's called Caldecott, like that, or with 1 T, I don't remember the name. But with this, you can have the tunnel to your app, to your Cloud Foundry instance, and there, Caldecott will provide you the credentials for your MySQL, let's say. And you could have them run MySQL host, blah, 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 and then do this kind of stuff. But not a shell in the sense of a remote bash or something like that. This is not possible at the moment. Yeah.
But this is only for the services, not for the app.
Exactly. It's to get stuff from the service. And then from Cloud Foundry, in that URL here, there is some stuff you could do for administration with VMC. Like start, stop, delete the app, do the binds of the services, getting log information, crash log, stuff like that. Like fire more instances, for example. All this stuff you can do, but not really log in into the. So it's not like Amazon server, basically.
Are there plans to implement idling of apps?
What do you mean by that?
Yeah, if the app is not active or it doesn't receive requests over the HTTP router for, let's say, an hour, that it will shut down that and restore it after it receives.
a new one or something like that. As far as I know, there is nothing like that, because I'm not sure if the. I mean, I'm really not sure if you will have cost depending on how much your app runs, or you will have cost per RAM or per disk. You know what I mean?
Yeah, at the end, in the cloud, RAM is your most valuable thing.
Exactly, but the thing is, because the app is there, doesn't mean we are charging you. You know what I mean?
Yeah, but we
But of course, you have a limit of how much RAM you want to have.
we use the open source Cloud Foundry,
Mm-hmm.
and so we're really tight with RAM, and something like that would come in really handy. And I think for you as well, when you have a lot of apps running and they are not really used.
Yeah, I mean, I know, I see the point, but as far as I know, there is no plan for something like that. Yes.
I was thinking of something similar, like, namely the auto-scaling of the number of instances that will be running. So,
And I'm not sure if this will be part of the paid offering or something like that you could fire or remove instances. And also, I don't know if any of the other providers they have that already, like AppFog or something like that. I cannot talk about that, but yeah, I see the need, but if you see the stats, I think it was the command. You can get some info already from there and see if you need more or not. So you could build something like that if you wanted to, or a partner could offer that, or we could offer that. If it's in the plans or not, I don't know. But it's doable, let's say. Some other questions? Yes?
Other plans to improve the docs for the open source version?
I hope. So there are some docs on GitHub. I think it's OSS docs, something like that. Okay, yeah. And then you have what you find here in the Cloud Foundry website, docs.cloudfoundry.com, and then usually the blog is something interesting to follow here, or the .org blog, because sometimes we just blog there, like in the closure support, which is not really support because it's not supported by default in cloudfoundry.com, but you can actually run it. That is advertised as a blog post in the .org website. So, yeah, we should do better there, let's say. Yeah. You could have all the t-shirts today, but you were too late for the questions.
Autoscaling of databases. You have, I think, autoscaling of instances.
Mm-hmm.
Support, but not. Is there something?
You can add more instances of one service, but then your client needs to know how to connect there. And most of the time, when we provide auto configuration, we provide for one instance of that particular service. So let's say you have two MySQLs, then I'm not sure if the auto configuration will just give you the first one that finds, or how that will work. So if you want to configure yourself the connection to the service, then you need a library, in the case of MongoDB, that knows how to connect to many MongoDB instances, or in the case of RabbitMQ to do that, or Redis, or whatever. So there is nothing automatic there for the app part, as far as I know. Yeah?
Do you plan to integrate Vertex support as well?
There is Vertex support. There is already, in the same way, basically, as how you can run Closure, and there is actually a blog post explaining how to run Vertex apps there. That's the reason why we have Java 7 in the support, is that you can actually run Vertex. Yes.
Staccato has support or runs the apps inside LXCs, and I think you run apps inside user space. Is there, or what are the plans for the future?
About the exact architecture, I don't know so much about how it is. I know there will be like support for groups and things like that for your apps, and like stuff that are restricted only for your for a group of developers or stuff like that. But the exact details, I don't know.
What is the roadmap for the whole project? Like, what our planned features that
I don't know, please. Okay, there you go. Thank you very much, and thank you for having me here.